Most people believe ancient Rome left nothing unexplained. Its roads, aqueducts, temples, and monuments feel familiar, documented, and understood. But in Baalbek, that confidence quietly collapses. Visitors come to admire towering Roman columns and leave convinced they have seen another triumph of imperial engineering. Yet beneath those columns lies something far more troubling. Stone blocks so large, so precisely cut, and so carefully positioned that even modern engineers struggle to explain them. These stones were not decorative. They were nashabag, they were functional, and they should not exist at this scale in the ancient world. This is not a story about myths, legends, or speculative fantasy. It is a question of weight, tools, records, and silence. Who quarried these stones? Who moved them? And why did the Romans, who documented everything, say nothing about the most extreme construction feat at the site? Tonight, we will examine the evidence step by step, strip away assumptions, and confront what Baalbek forces us to admit about ancient engineering, and about how much of history we may still misunderstand. When people arrive at Baalbek, their attention is guided in a very specific direction. Guidebooks, signs, and tour routes all point upward, toward columns, capitals, and decorative stonework. The visual focus is intentional. It reinforces a familiar narrative. Rome came, Rome built, Rome conquered space with architecture. The most photographed structure is the Temple of Jupiter. Its surviving columns rise more than 20 meters high and immediately communicate scale, authority, and imperial confidence. These columns fit neatly into what we already know about Roman engineering. They resemble other Roman temples across the empire in style, proportion, and construction logic. Nothing about them forces us to rethink Roman capabilities. What almost no visitor is encouraged to examine closely is the base beneath those columns. The temple does not rest directly on bedrock. It sits on a massive artificial platform, an engineered podium composed of stone blocks that are radically different from the Roman masonry above. This lower layer is not decorative. It has no inscriptions, no reliefs, no aesthetic flourishes. Its only purpose is structural stability. At Baalbek, the visual story tells us Rome built this. The physical evidence tells us something more complicated. The most extraordinary engineering achievement at the site is also the one least acknowledged, least explained, and least discussed. And once you notice that disconnect, it becomes impossible to ignore. The moment the foundation stones are measured instead of admired, the discussion stops being architectural and becomes mechanical. The most famous elements of the podium are known as the Trilithon, 3 enormous limestone blocks set into the western retaining wall of the platform. Each block is approximately 19 meters long, over 4 meters high, and nearly 4 meters deep. Conservative weight estimates place each stone at around 800 tons. Some calculations, depending on limestone density, push those numbers closer to 1,000 tons per block. These are not abstract figures. For comparison, the largest stones used in the Great Pyramid of Giza weigh roughly 70 to 80 tons. Roman obelisks transported from Egypt to Rome typically weighed 200 to 300 tons, and those operations were considered exceptional, celebrated, and heavily documented. The Trilithon stones are 3 to 4 times heavier than the largest stones Rome ever admitted to moving. Size alone would already raise questions. Precision turns those questions into serious problems. Each Trilithon block is cut into a near-perfect rectangular form. The faces are flat across many meters. The edges are straight, and the angles are consistent. When placed together, the joints between stones are so tight that no filler material was needed. There is no mortar, no lead clamps, no corrective shimming. The stones rely entirely on their own geometry. From an engineering perspective, this matters more than weight. Heavy stones can be moved with brute force and time. Precision requires control over cutting, alignment, and final placement. A stone weighing hundreds of tons cannot be adjusted easily once it is set down. If the angle is wrong by even a few millimeters, the error becomes permanent. The Trilithon blocks are not merely stacked. They are integrated into surrounding masonry in a way that distributes load evenly across the platform. This requires advanced planning. The stones had to be quarried to exact specifications long before they were ever placed. That implies a clear design blueprint and an understanding of how the entire structure would behave under stress. Below and around the Trilithon are additional massive stones, slightly smaller, but still far beyond ordinary Roman scale. Together, they form a continuous structural logic that prioritizes stability over appearance. Nothing here is decorative. Every decision appears driven by function. The surface finish of the stones deepens the mystery. The faces are unusually smooth, lacking the chisel marks typical of Roman quarrying. Roman stone cutting usually leaves visible patterns, parallel grooves, stepped surfaces, or pecking marks from iron tools. At Baalbek's foundation level, many faces appear planed rather than chiseled, as if shaped by abrasion or sawing rather than impact. Some engineers have suggested the use of large stone saws or wire cutting methods combined with abrasive sand. These techniques are known in limited ancient contexts, but not at the scale required to shape blocks of this size with consistent accuracy. No Roman tools capable of sustaining such pressure over such distances have ever been recovered. Then there is placement. The Trilithon stones sit approximately 7 meters above ground level, not at the base of the quarry floor. This means they were not only transported across uneven terrain, but also lifted into position with control and precision. Lifting is exponentially harder than dragging. Gravity does not forgive mistakes. Modern engineers emphasize this point repeatedly. Moving a heavy object is one challenge. Placing it accurately at height is another entirely. The Baalbek foundation required both, repeatedly, without visible error. Nothing in surviving Roman construction manuals describes procedures for handling stones at this scale. Nothing in Roman art depicts machines capable of doing it. And nothing in Roman historical writing boasts about it, an absence that grows more difficult to justify the longer one examines the stones themselves. At this stage, the question is no longer whether the stones are impressive. That is obvious. The real question is whether the people traditionally credited with building Baalbek possess the tools, methods, and institutional knowledge necessary to execute this level of precision under these conditions. And that question leads directly to the quarry. Roughly 800 meters southwest of the temple platform lies the quarry that supplied Baalbek's stone. This location removes any lingering doubt that the massive foundation blocks were natural formations later repurposed. They were quarried intentionally, shaped deliberately, and prepared for transport. The most famous block in the quarry is known as the Stone of the Pregnant Woman, also called Hajar al-Hibla. It measures approximately 20.5 meters long, 4 meters high, and 4.5 meters wide, with conservative weight estimates of 1,000 tons or more. The stone is partially detached from bedrock, with clear extraction trenches visible along its sides. This is not a failed experiment. It is a work in progress that was deliberately abandoned. What changed the discussion significantly was what archaeologists discovered beneath it. In 2014, researchers identified another stone directly below the pregnant woman stone, even larger, with an estimated weight approaching 1,650 tons. A third massive block lies nearby, similarly shaped and similarly unfinished. Together, these finds confirm something critical. The builders were not struggling to reach the size of the Trilithon stones. They were attempting to exceed it. This matters because it reframes the project's ambition. The quarry shows escalation, not limitation. Whoever planned the foundation intended to move stones larger than those already placed at the temple. That plan did not fail due to lack of imagination. It stopped abruptly. Mid-process, from an engineering standpoint, the quarry stones answer several important questions while raising new ones. First, they confirm intent. The stones were squared, leveled, and shaped for architectural use. They were not random boulders left behind because they were inconvenient. The extraction trenches indicate a controlled process, with consistent dimensions and smooth cutting surfaces. Second, they reveal planning depth. Quarrying a block of this size is not done casually. The builders committed enormous labor and time before knowing whether transport would succeed. This suggests confidence in a method they believed would work. Third, they expose interruption. The stones were abandoned in place, not broken up, not repurposed, not finished later. No later culture attempted to complete the job. The work simply stopped and never resumed. This pattern is difficult to reconcile with Roman practice. Roman construction projects were centrally organized, well-funded, and aggressively completed. When Romans abandoned projects, they usually left written records explaining why. War, economics, political collapse. At Baalbek, there is no such explanation. If the Romans had initiated this quarrying effort, several questions arise immediately. Why did they abandon stones larger than anything they had successfully moved elsewhere? Why did they not reuse the partially extracted material? And why is there no record, no inscription, no historian's comment describing a failed or halted megaproject? The quarry also challenges the idea of gradual experimentation. The stones were not progressively larger test pieces. The builders moved directly to extreme sizes. This suggests they were not learning as they went. They were executing a plan based on prior knowledge or experience. From a logistical perspective, the quarry location compounds the problem. The route from quarry to temple platform crosses uneven terrain with slight elevation changes. Even with ideal conditions, transporting an 1,600 ton block would require not just force, but control over friction, alignment, and momentum. Losing control of such a mass would be catastrophic. And yet, the builders clearly expected transport to be possible. The stones were shaped accordingly. Their dimensions match the foundation blocks already in place. This consistency indicates a unified construction philosophy spanning quarry and platform. The abandoned stones therefore represent more than an unsolved puzzle. They are evidence of capability paired with disruption. Someone had the knowledge to plan this work. Something prevented them from finishing it. When later builders, Phoenician, Greek, Roman, arrived at Baalbek, they inherited not just a sacred site, but an incomplete engineering legacy. What they did with that inheritance is revealing. They built upward, not deeper. They respected the foundation, relied on it, and never attempted to replicate it. The quarry stands today as silent testimony to a construction effort that reached beyond what history is comfortable explaining, and then vanished without leaving its name behind. To evaluate whether the Romans could have built Baalbek's megalithic foundation, the discussion must move away from admiration and toward constraints. Roman engineering was extraordinary, but it was not unlimited. Its capabilities are well studied because the Romans documented them extensively. Roman lifting relied primarily on treadwheel cranes, compound pulleys, capstans, and coordinated human labor. These systems were effective within known limits. Reconstructions based on ancient sources show that even the largest Roman cranes could lift 50 to 100 tons under optimal conditions. Exceptional operations, such as raising obelisks, used multiple cranes in synchronized configurations, pushing practical limits to 200-300 tons. These feats were rare, celebrated, and carefully recorded. Our understanding of Roman methods is grounded in primary sources, especially Vitruvius, whose treatise De Architectura describes machines, materials, and construction logic in precise detail. Vitruvius explains cranes, pulleys, and leverage ratios, but he never hints at systems capable of handling stones approaching 800 or 1,000 tons. If such methods existed, this is precisely where we would expect them to appear. Historical writers reinforce this boundary. Pliny the Elder devoted significant attention to engineering marvels, quarrying, and the transport of massive stone. He describes the movement of obelisks as astonishing achievements that strained Roman ingenuity. Yet Baalbek's foundation, far more extreme in scale, goes unmentioned. This silence matters because Roman culture rewarded documentation. Major public works were opportunities for imperial propaganda. Engineers were named. Emperors claimed credit. Techniques were repeated across the empire to demonstrate power and competence. None of that pattern appears at Baalbek's foundation level, beyond lifting. There is the issue of transport. Roman methods for moving heavy loads involve sledges, rollers, lubricated tracks, and large labor forces. These systems worked for hundreds of tons over relatively controlled routes. But the quarry-to-platform path at Baalbek includes uneven ground and subtle elevation changes. Maintaining control of an 800-ton block on rollers is not simply difficult, it is unstable. One failure would shatter months of labor and risk countless lives. Even more problematic is placement accuracy. Roman construction tolerated adjustment. Mortar allowed correction. Smaller blocks could be reseated. The Trilithon stones do not allow this margin. They had to be placed correctly the first time. Roman cranes, as reconstructed, lacked the fine control necessary to maneuver such mass with millimeter precision at height. Engineers who have modeled these scenarios consistently reach the same conclusion. Roman technology could explain the temples above the podium, but not the podium itself. The gap is not incremental. It is categorical. One argument often raised is that Roman engineers may have possessed undocumented techniques. This claim weakens under scrutiny. Undocumented does not mean unrepeatable. If Romans had mastered methods to handle 1,000-ton stones, those methods would have transformed imperial construction everywhere. Rome itself would be the first place to showcase them. It was not. Instead, Baalbek stands alone. No other Roman site approaches this scale. No transitional experiments appear elsewhere. No partial attempts survive. The foundation emerges fully formed, unmatched, and then never repeated. That pattern is not consistent with Roman innovation. Roman engineering evolved through repetition, standardization, and diffusion across the empire. Baalbek's megalithic platform fits none of those behaviors. At this point, the question shifts. It is no longer could the Romans have done this, but why would they do this once, in one place, without explanation, and never again? That question points away from Roman capability and toward inheritance. In Roman history, silence is rarely accidental. The Roman state documented power through stone, text, and repetition. Major construction projects were not just functional, they were political statements. Inscriptions named emperors, legions, donors, and engineers. Coins celebrated completed works. Historians recorded extraordinary feats precisely because they demonstrated Roman superiority over nature and rival cultures. At Baalbek, this pattern abruptly breaks. There are Roman inscriptions at the site, but they refer exclusively to the temples above the podium, not to the massive foundation beneath them. Dedications name emperors in poem. They commemorate expansions, restorations, and ritual functions. Nowhere do they describe the quarrying, transport, or placement of the largest stones at the site. This omission is not minor. It is structural. Consider what Roman authors chose to record elsewhere. Pliny the Elder described the transport of Egyptian obelisks in remarkable detail, emphasizing the risks, the machinery, and the human cost. Vitruvius explained construction methods down to pulley ratios and material properties. When Romans did something difficult, they wrote about it. The Baalbek Foundation would have been among the most difficult engineering achievements in Roman history. Yet it appears in no surviving Roman text. No author mentions a failed attempt. No engineer boasts of success. No emperor claims credit. No relief depicts the operation. This absence is especially striking given Roman pride. Engineering was a core element of Roman identity. Roads, bridges, aqueducts, and harbors were used as proof of civilization itself. To leave the greatest stone-moving operation in the empire undocumented would contradict everything we know about Roman behavior. The silence becomes even louder when we look at repetition, or the lack of it. Roman construction methods were standardized and reused across the empire. When a technique worked, it spread. The concrete dome of the Pantheon was not unique. Aqueduct design repeated across provinces. Amphitheaters followed recognizable patterns. The Baalbek Foundation does not fit this logic. There is no second example, no earlier prototype, no later imitation. Not in Rome, not in North Africa, not in Asia Minor, nowhere. If Roman engineers had mastered a method for handling 800 1,000-ton stones, it would have reshaped imperial architecture. Instead, Roman builders continued using far smaller blocks everywhere else, even in projects of enormous symbolic importance. The documentation gap also applies to failure. Romans recorded setbacks when they mattered, collapsed structures, abandoned projects, or technical limits. At Baalbek, the quarry stones show a project that stopped mid-process, yet Roman sources provide no explanation. No war interruption, no funding crisis, no imperial decree. This silence suggests something uncomfortable. The Romans may not have been responsible for the foundation at all. In archaeology, attribution is often based on proximity. If a Roman temple stands on a foundation, the foundation is assumed Roman unless proven otherwise. At Baalbek, that assumption carries more weight than evidence. When the Romans encountered existing monumental structures elsewhere, they frequently reused them. They built on Etruscan platforms, incorporated Greek temples, and repurposed earlier city walls. In such cases, they documented what they added, not what they inherited. The pattern at Baalbek fits this behavior precisely. The Romans documented their temples. They left the foundation unnamed. Silence, in this case, is not ignorance. It is a boundary line. It marks the edge of Roman authorship, and once that line is acknowledged, the question shifts decisively. If the Romans did not build the foundation, who did and when? Once the assumption of Roman authorship is set aside, the timeline at Baalbek becomes broader and more complex. Archaeological evidence indicates that the Bekaa Valley has been continuously inhabited for at least 9,000 years. Long before Roman legions arrived, the site was already regarded as sacred. Local traditions associate the area with Phoenicians and earlier Canaanite groups, who referred to the city as Baalbek, often translated as City of Baal, when the Greeks later controlled the region. They reinterpreted the site through their own religious framework, calling it Heliopolis, the city of the sun. The Romans inherited both the name and the sacred status. This layered religious history matters because sacred sites are rarely chosen at random across the ancient world. Later civilizations consistently built temples on locations already considered powerful or important. The choice of Baalbek as a Roman religious center does not require Roman discovery or innovation. It only requires recognition of an already monumental place. Could the Phoenicians or other pre-Roman cultures have built the megalithic foundation? The Phoenicians were accomplished builders and traders. They constructed harbors, city walls, and temples across the Mediterranean. However, no confirmed Phoenician structure elsewhere approaches the scale or precision of Baalbek's foundation. Their surviving architecture relies on smaller stone blocks, mortar, and conventional stacking methods. The leap from known Phoenician construction to 800,000, 1,600-ton precision megaliths is extreme and unsupported by comparative evidence. The same limitation applies to Greek construction. Greek temples emphasize proportion, visual harmony, and sculptural refinement. Even the largest Greek foundations use stones far smaller than those at Baalbek. Greek engineering excelled in geometry and aesthetics, not extreme mass handling. This leaves a third possibility: inheritance from an earlier, largely unknown construction phase. Under this model, the megalithic foundation predates Phoenician, Greek, and Roman occupation. It was built by a culture whose technical knowledge did not survive in written form, or whose records have not yet been found. Later societies recognized the foundation's stability and reused it rather than attempting to replicate it. This is not an exotic idea in archaeology. Many ancient cities sit atop earlier layers whose builders are poorly understood or entirely anonymous. What makes Baalbek different is not the existence of an earlier phase, but the level of engineering competence that phase implies. Several physical clues support this inherited foundation model. Weathering differences. The foundation stones show erosion patterns that appear more extensive than those on Roman masonry above, suggesting longer exposure to the elements. On the construction of philosophy, the foundation is purely functional. No decoration, no inscriptions, no symbolic elements. Roman architecture, by contrast, is overtly expressive and ideological. Continuity without replication. Later builders relied on the platform, but never attempted to expand it using the same methods. Inheritance also explains the quarry abandonment if the original builders were interrupted by social collapse, environmental change, or population movement, the project would slow abruptly. Later cultures, lacking the original methods, would leave the unfinished stones in place. Crucially, this model does not require speculation about advanced machines or lost super technology. It only requires acknowledging that technical knowledge can disappear. History provides many examples. Roman concrete formulas were lost for centuries. Damascus steel vanished. Greek fire left no reproducible recipe. Knowledge is fragile. At Baalbek, the foundation may represent a peak of localized engineering expertise that did not spread, was not recorded, and did not survive its creators. The Romans, practical and efficient, would have recognized the value immediately. Building monumental temples on an already indestructible platform would save time, labor, and resources. They added what they knew: columns, courtyards, ornament, and left untouched what they did not understand. This interpretation resolves several problems at once. It explains the silence in Roman records, the absence of parallel Roman examples, the unfinished quarry stones, and the stark contrast in construction style. It does not answer every question, but it aligns more closely with the evidence than any single culture explanation. And it leads directly to the final issue: how the foundation performs under stress, and what that reveals about the mindset of its builders. Baalbek sits in a region where earthquakes are not occasional disasters. They are a recurring reality. The Bekaa Valley lies along an active fault system that has produced powerful seismic events for thousands of years. Any long-term construction here must contend with lateral movement, vertical shock, and repeated stress cycles. The contrast between what failed and what endured at Baalbek is therefore highly instructive. The Roman superstructure suffered badly. Historical records and physical evidence show that earthquakes toppled columns, fractured walls, and reduced much of the Temple of Jupiter to ruins. Of the original 54 columns, only 6 remain standing. This pattern is exactly what engineers would expect from tall, slender stone elements subjected to seismic forces. The foundation beneath them tells a different story. Despite centuries of earthquakes, some strong enough to devastate entire cities, the megalithic podium has not shifted. The largest blocks show no meaningful cracking, displacement, or settling. Their joints remain tight. Their alignment remains true. This is not luck. It is performance. Modern structural analysis helps explain why. First, mass and geometry. Extremely large stones behave differently under seismic stress than stacked smaller blocks. Their sheer mass dampens vibration. Once properly seated, they resist horizontal movement far more effectively than layered masonry. Second, joint precision. The near-perfect contact between stones allows micro-movement without loss of structural integrity. During an earthquake, energy can dissipate across the contact surfaces rather than concentrating at weak points. Mortar, by contrast, often becomes the failure zone. Third, load distribution. The foundation stones are arranged to spread vertical and lateral loads evenly across the platform. There are no abrupt transitions in mass or height. This continuity reduces stress concentrations during ground motion. What matters here is intent. These are not accidental benefits. The builders understood, explicitly or implicitly, how stone behaves under long-term stress. They prioritized stability over visibility. The foundation was never meant to impress an audience. It was meant to last. This mindset differs sharply from Roman architectural priorities. Roman monuments emphasize grandeur, symbolism, and immediate visual impact. Longevity mattered, but not at the expense of expression. At Baalbek, the most resilient component is also the least expressive. Engineers who have examined the site note that replicating this foundation today would require extensive modeling, precision surveying, and heavy machinery, tools designed specifically to manage seismic risk. The ancient builders achieved similar outcomes without leaving behind diagrams, calculations, or written explanations. This is where the conversation often becomes uncomfortable. The evidence suggests not just technical capability, but structural intelligence, a deep understanding of how to build for a hostile environment over centuries. That level of understanding is not easily attributed to trial and error at this scale. The performance record is the final metric. The Roman additions failed where the foundation did not. Time, earthquakes, and gravity have acted as impartial judges, and they have consistently favored the megalithic platform, whatever its origin. The foundation at Baalbek was built with priorities that extend beyond a single generation or a single empire. It was designed to endure conditions that eventually destroyed the very structures that drew attention away from it. Baalbek does not tell us who built the foundation. It tells us something more uncomfortable, that our understanding of ancient engineering is incomplete, and that some capabilities existed briefly, locally, and then disappeared without explanation. This is not myth, it is measurable stone, still standing, still aligned, still resisting gravity and time. So the question is not whether Baalbek is mysterious. The question is whether we are willing to accept that history sometimes preserves outcomes without preserving methods. If a civilization before Rome could achieve this and leave no name behind, what other assumptions about the ancient world deserve another look? What do you think Baalbek represents? Lost knowledge, inherited genius, or something we have not yet learned to recognize?